Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we start a new unit, and this unit is all about solving a type of equation we haven't ever solved before. These equations are called quadratics. So we've talked about quadratic polynomials. We know that those are polynomials where the highest degree is 2, so we're going to see a 2 in our exponent, but we haven't talked about how to solve these. We're going to use some methods we learned in our last unit about factoring. Those are going to help us solve some of these, but then we're also going to learn some other methods for solving. So let's just jump right in. Today we learn a method called the square root method. So go ahead and try to solve these three equations on the first page. Just pause the video. And some you may be able to solve, some you may not know what to do. But pause the video, give it a shot, and then come back and join us for a discussion. Okay, so for the first one, again, we have x squared is equal to 25. Now, you may just think in your head, okay, well, I know that x could be equal to 5. Because 5 times 5 is 25, or 5 squared is 25. And you're correct. So this is a solution to that equation. Now, if I'm talking about how to find this solution, what inverse operations to use, well, if it's x squared, to get the x by itself, we need to undo the square. So the inverse operation of squaring something is taking the square root. So we've got to take the square root of both sides. So we take the square root of x squared, we get x. And when we take a square root, or when we apply the inverse operation of a square root to both sides, we actually are going to get a positive and a negative root. What this means is that we're going to have two solutions. We're going to have a positive solution and a negative solution. In most cases. There are some cases where we only get one, and we'll talk about that a little later. So we end up getting x is equal to positive 5 and x is equal to negative 5. So there's actually two solutions to this equation. And if you think about it, we always think about the positive root, right? You probably came up with the number positive 5 as an answer. You may have not remembered about the negative 5. But if we think about it, well, if I square negative 5, negative 5 times negative 5 is positive 25. So this equation is true if I substitute in negative 5 for x. So in this case, we end up with two solutions to this quadratic equation. Let's look at the one on the right. X squared is equal to negative 16. So we have the same thing here. We're going to be taking the square root of both sides. So I'm going to get x is equal to the positive and negative root of the square root of negative 16. The problem here, though, is if you punch the square root of negative 16 into your calculator, you're not going to get an answer. This does not exist, or at least the answer is not a real number. Now, in Algebra 2, you'll talk about imaginary numbers and complex numbers, and those are just numbers we're really unfamiliar with. They don't look like, quote-unquote, normal numbers because they're not real, right? If you think back to one of the very first lessons we ever did in this Algebra 1 curriculum, we talked about the different number categories, right? And we said that all of the numbers, right, that we know so far are considered the real numbers. And then inside, right, we had rational, we had irrational, and we could break these categories up further. But the point was, every single number that you currently know up to this point was a real number. And so when I say there's no real number solutions, there may be solutions. You just won't know what they are because you're not familiar with that type of number yet. But you will be in Algebra 2. So the square root of negative 16 actually has no real number solutions. So our answer here is no solution. And technically, I wouldn't mark it wrong in this class, but technically we should say no real number solution. Because there is a solution to this equation, But the answer is not a real number. It's going to be called, it is called an imaginary number or a complex number. And again, you'll talk about those in a different course. Now you may think, well, why isn't there a real number solution? Why isn't the square root of negative 16 negative 4? Well, if we're taking a square root, we're looking for a number that we can multiply by itself to get the number underneath the radical sign. And there's no real number that you can multiply by itself to get negative 16. And we can check, right? If we did negative 4 squared is equal to negative 16. Well, negative 4 times negative 4 gives me positive 16. And then all of a sudden this equation is false. It's not true. So if you're ever trying to take the square root of a negative number, this is something to keep in mind as we move forward with this unit. There is no real number solution. So if you ever have a negative number under the radical sign, you can just stop and say no real number solution. A negative number outside of the radical sign is okay, just not inside. All right, our last example here. We're going to take the square root of both sides, and I get x is equal to plus or minus the square root of 0. Well, the square root of 0 is just 0. So you can write x is equal to plus 0, x is equal to negative 0, but that doesn't really make sense, right? Because 0 is 0. It doesn't matter what sign you put out in front of it. In fact, 0 is neither positive nor negative. So if you're ever taking the square root of 0, you're just going to get one solution, and that is 0. So these are the three possible scenarios you may run across here. You could have an equation where there's two solutions, a positive and a negative. You could have an equation where there's no real number solutions, or you could have an equation where there's one solution. And that's what's going to go in these blanks here. This unit will be solving all different types of quadratic equations. These are equations where there is a variable in the equation that is being squared. Right? A 2 in the exponent means we are squaring the base. Quadratic equations can have 0, 1, or 2 solutions. Now, we just did very simple equations that we only had to take the square root, and there were no other inverse operations. It may be that we have to do other inverse operations before we take the square root. So what I'd like you to do is pause the video, see if you can complete these two other equations on my screen. And again, you're going to have to do more than just one inverse operation. So see how far you can get, and then you can join us back for a quick review. All right, so for this equation on the left, before I take the square root, I want to get the x squared by itself. So I'm going to divide both sides by 3. That gives me x squared is equal to 9. Then, because the x squared is now by itself, I will take the square root. I will get x is equal to plus or minus the square root of 9. So x is equal to positive 3. And x is equal to negative 3. So two possible, well, not possible, but two solutions here. X can be either of those numbers. For the one on the right, my inverse operation is going to be adding 11 to both sides to start. So I get x squared is equal to 81. Then I can apply my square root. And I get x is equal to, and I'm going to stop writing this in between step. If I take the square root of 81, I get 9. So x can be equal to positive 9, and x can be equal to negative 9. Both of those are solutions. It's important to remember as you work through these different equations that you want to get the variable by itself before you take the square root. So let me just show you what it would be like if you didn't take the square root first, or if you did take the square root first and didn't do those other inverse operations first. Well, on the left, for the left equation, if we took the square root first, we would get the square root of 3x squared is equal to plus or minus the square root of 27. And you may just immediately see what problem we're running into, right? The square root of 27 is not a rational number. It's irrational. So we would have to go through the process of simplifying a radical, and one that is not rational. So we get the square root of 3x squared is equal to plus or minus the square root of 9 times the square root of 3, because we can simplify the square root of 9. Right? So our next step may be, and I'm actually going to break up the left-hand side to the square root of 3 and the square root of x squared is equal to plus or minus 3 times the square root of 3. Divide both sides by the square root of 3. I get the square root of x squared is equal to plus or minus 3, because these simplify. And then I get x is equal to plus or minus 3. So x is equal to positive 3 or negative 3. By the way, this is another way you may see your answers written. You don't have to break them apart. You can just leave the plus minus sign out front. And that will show me or your reader, whoever's reading your paper, that that means you have two solutions. Now you can see we were able to solve this by taking the square root first, but it was way more complicated, right? And a couple of extra steps. So it would have been way easier if we had just divided by 3 first. Then we just have 2 steps. Now, not all of them can you even solve if you take the square root first. If you take the square root of the right-hand side, well, not only do you have an irrational radical on the right, but you also have something that's a little bit different on the left. X squared minus 11 is a difference, whereas 3x squared was a product, right? I was multiplying the 3 and the x squared together, so I could break those up. But you can't do this. I'm not allowed to do x squared minus the square root of 11, right? This is not okay, going from up here to down there. So you'd be stuck with that entire radical, and you would not be able to get the x squared by itself. You have to go back up and restart. So there are some times where you can still solve the equation by taking the square root first, but it doesn't work every time. And regardless, it's going to be far easier to do the square root part last. So do all the inverse operations until you get the variable by itself, and then take the square root of both sides. And that's exactly what I said at the top of the next page. When solving a quadratic equation, we should try to isolate the variable before applying the square root property to both sides of the equation. Okay, let's do 2 more practice problems. Let's do number 5 and we'll do number 8. So pause the video, attempt 5 and 8. We'll review and then we will be done with the video. Okay, number 5, we're going to divide by -4 first. That's going to give us x squared is equal to -18. Take the square root of both sides, and we should immediately see the problem we run into, right? We're going to be taking the square root of a negative number, which means that there are no real solutions to this equation. Again, we can stop right away. Number 8, we are not so fortunate. Subtract 4 from both sides. Get 9x squared is equal to 576. I'm then going to divide both sides by 9. This gives me x squared is equal to 66, I believe. Just check my math on that. 64. Sometimes my mental math is not as good as I think it is. So x squared is equal to 64. If I take the square root of both sides, that's going to give me x is equal to plus or minus 8. So again, you can write it like this, or you can write it as x is equal to 8, or x is equal to -8. Both of those are solutions. All right, so this is our first method of solving quadratic equations. This method will not work for all types of quadratic equations, but it is the most simplest method, so we're teaching it first. In our next video, we'll talk about a more complicated method of solving quadratic equations when we're given a different type, and this method is no use to us. So hope to see you then. As always, enjoy the rest of your day.